Good evening, everyone. Welcome to this session on GeoAI and Generative AI in ArcGIS. With me, my colleague, Mr. Ahmed. We are going to present you the advanced AI in ArcGIS. Yeah. So to begin with, let's know about the audience. How many of you are using imagery? How many of you are using imageries? Okay. How many of you are using imagery as only base map? Only base map. Okay. How many of you are really analyzing the imageries? Okay. Okay. Good. And now I can, filter out more. What kind of analysis that we are looking into it? What are the analysis that you are doing? All the analysis. Finish putting it out. Fantastic. Most welcome. Okay. And anyone else? Another kind of analysis that you are doing? Yes. Sorry. You are doing classification. Okay. Anyone else? Yes. Feature extraction. Okay. Okay. So now we have a very nice heterogeneous group who are doing from traditional classification to advanced AI analysis of medallions here. So let's begin with it.
Actually, I was going to also ask another question. How many of you know absolutely nothing about AI? Okay, good. All right.
To say that I have no idea about AI.
Okay.
Okay, good. Okay, thank you. So we are going to give an intro of the what is GeoAI is all about, where you can find AI in ArcGIS. One more question that comes up: how many of you are still using not still using the Arc Pro? I hope everyone is using Arc Pro, right?
I don't want to see any hands up. Arc Map still? Still Arc Map. Okay.
We should encourage them to use more on Arc Pro.
Yeah.
And because AI comes in Arc Pro, and there are a lot of tools and functionalities that you work in Arc Pro for AI, and that's why we are going to concentrate on it. And how can we use AI in real world examples? We are going to show you some kind of a demo. What kind of life cycle we are talking about? When you talk about AI, there are a lot of things. AI. What is AI and what kind of life cycle we are talking about? Then we are going to see some of the models in GeoAI. What are we going to do on these models and with some demos? Yeah. And there is a new functionalities that has come up, which is called AI assistance. So we are going to deal and explain that also. So starting with it, we all know when we say AI, okay, I have my AI in my phone, I have my AI in my smartwatch, I have my AI everywhere, literally everywhere. So it's a kind of a artificial intelligence is, of course, the knowledge that is being put to a system and then making it learn and then give a kind of a modeling to provide us a kind of a little decision making kind of a thing, let's say. But what are we actually imparting into the AI? What kind of results we are expecting in the AI? That depends upon what kind of inputs that you are going to give. Here we are going to concentrate on most of the imageries, right? So I'm going to give imagery as my input. I'm going to make the system learn certain aspects and then try the system to put analyze on other areas where I have trained it. Okay, so that's what we are going to see. So literally, AI is used everywhere, from crime predictions to maintenance, predictive maintenance, to advanced satellite intelligence, to securities. Everywhere the AI is used. And AI is a broader spectrum. AI is a broader spectrum from where we have the machine learning. We make the machine learn based on our inputs. And the niche part is the deep learning. Yeah. So we are talking about the hierarchy of the intelligence, which goes as deep learning, machine learning, and artificial intelligence. To talk more about it, Amit?
Absolutely. So when we talk about this kind of hierarchy of artificial intelligence in general, okay, think about like video games, right? You know how like enemies spawn in a particular area and they know that they're going to attack you and can find you and all of that. That is actually AI. But that is a very general kind of AI based on game theory. That's not the kind of learning that's being done like deep learning and all of that. Things then moved forward from that with different applications to attempt to do machine learning, making the machine understand. And that is very different from algorithmic kind of solving of problems. So you're not actually writing, 1 + 1 = 2. You're just constantly teaching the machine that 1 + 1 is equals to 2, 2 + 2 is equals to 4, until it eventually can figure out that result itself. Now, with machine learning, one of the main issues with that is that there isn't that much depth, there isn't that much complexity. Let's call it dumber. So in order to make it smarter, in order to give it literally more neurons to think of as equivalent to a brain, that's what deep learning is for. And that then applies multiple layers of these neurons that then allows for that complex analysis to be done. I've got a fun little story that kind of helps explain things a little bit. The way all of this works, when my sister was extremely young, when she was a baby, she first saw a cat, right? And, all right, a cat, animal, 4 legs, doesn't really talk, etc. A couple days later, we were in the desert and she saw a camel. She looked out the window and said, cat, because it's animal, 4 legs, doesn't talk. That's what it is, right? And that's kind of the main thing about machine learning and deep learning is that you've got to provide the appropriate set of examples. And you've got to not only provide what is correct, but you also have to teach it what is incorrect. And that's what's extremely important about that machine learning and deep learning. And so it all really builds itself upon the data that's being fed into the different models. We're going to talk all about that. So now we're AI and spatial analysis, the conventional spatial analysis. Think, the old algorithmic ways of doing change detection or all of the different NDVIs and things like that, right? Where that meets with artificial intelligence is where we get this intersection called GeoAI, geospatial artificial intelligence.
So to give a little bit perspective on this, many of the audience who are using imageries, they start using the imagery as a visualization. You interpret it. There is one set of manually understanding the pictures and manually understanding the ideas, what exactly the image talks about. Then comes the idea of digitizing it. So you know which picture is building, which one is road, and that's again a learning curve. Then comes the classification. The classification in terms of pixels were there traditionally. What we are doing were pixel classification. But when you talk about the higher end of classification or higher end of identifying the things, there comes the AI. We group the pixels, and we say if these pixels are grouped and it makes an object, that's for example a building, a tree, a manhole, that's where the GeoAI and the AI comes into the picture. Yeah, Amit.
And the point is to do that extremely quickly, right? The whole point is literally to have a team of 10,000 people just on one machine that's doing the work for you very quickly, just like that. Now, when it comes to like the GeoAI ecosystem, all of the different kind of layers where we have this support, and we're gonna break that up a little bit more and discuss each into detail. But all of our GeoAI or artificial intelligence. Actually, I want to kind of revise that. Not GeoAI. Let's say all of the AI capabilities within the ArcGIS, because there is more than GeoAI, and we are going to talk about that, is purely based on the Python API. And the main reason for that is because all of AI, all of machine learning in general, is mostly done on. So someone would say Python, and then I would go like, no, not Python. Actually, it's C++. And then Python just sits as a layer on top of that, right? As kind of an interface for the C++. That's what Python is. So the Python API, ArcGIS Learn, that's kind of the core. Everything else within the platform is 100% based upon that API. And then there's GeoAI tools and web services that are built there for you. So like the ability to train your own models, the ability to label your imagery, all of that, those are also built with the Python API and are kind of a larger scale. But then you can go one step further and use pre-trained models, which we're going to do a deeper dive in. But basically, it's a model that already kind of knows the basics of what you want it to do. And then finally, there's just apps and solutions, right? Something that is already empowered with AI that you could just use right off the shelf. So what can we do with machine learning? We can extract features, we can make predictions about data, about accidents and all of that. we can find patterns and clusters, we can detect anomalies and extract insights, right? That's great. A lot of really cool words on a screen. We're going to get to real life examples in the demonstrations after. But these are the kinds of patterns, these are the kinds of things where we see GeoAI kind of being as powerful as possible when it comes to your applications. Now, where can you find AI in ArcGIS? Well, hopefully one day I'll show this slide and I'll go like every one of those. But for now, we're actually still progressing within the integration. And every single time I show this screen, by the way, and this is something I'm very happy about. Every single time I show this slide, I need to update it because they're constantly adding new tools, constantly adding new capabilities. So we've got the API for Python, of course, just like I was mentioning earlier. But then we've got, ArcGIS analytics, notebooks, of course, online and enterprise both support it. On ArcGIS Hub and enterprise sites, by the way, in the latest version. Quick Capture and Survey 123. Not sure I updated the slide. Don't tell my boss. And ArcGIS Pro for intelligence, of course. Okay. So let's talk about some real world examples over here. This is an example where I don't remember where this was, but basically the whole point was to detect the kind of traffic that was moving around the city. And so by placing cameras at major intersections, we could monitor not only how many cars there were within that specific intersection, but also the specific type of car itself. So you see that some of them are being marked as cars, some of them are being marked as trucks. And all of that is happening in real time, and that data is constantly updating to reflect in a ArcGIS dashboard online. There's also road crack detection. This is another cool example, by the way, because it doesn't use live video feeds, but it does use a direct video camera that is placed on top of a road and that placed on top of a car, excuse me. And then the car is simply driving along the road. And automatically, the images that are being captured from the video are being geotagged frame by frame. The combination between the frames is being detected. So not each road crack isn't being identified twice, but rather only once. And then each crack is being detected in the image and the type of crack that it is, because there apparently are different types of cracks for the roads some are more severe than others. This is a little bit of an industry specific area. And then that information is all being, collected with AI and placed within that dashboard so that you can immediately understand where the road cracks are, what the type of them is, and how to immediately, have a potential solution to them. Now, of course, change detection. Change detection is another great thing where there used to be the algorithmic way, which was actually slower now. At some point, it used to be faster to run the algorithmic way than to go through the entire process of training your model and doing the inferencing and all of that. Inferencing is doing the actual detection, the actual, getting the result, getting the answer to the question that you're asking. So at some point, doing the algorithmic way was faster. Now, this is actually faster with machine learning. And basically, we can do all kinds of things. We can detect where the building footprints are and how they changed over time. Also, that is extremely helpful in damage assessment scenarios, for example, where there is something like a hurricane or recent wildfires, for example. Things like that are just automatically detected, the type of damage. In fact, we worked very closely with the government of Beirut after the extremely unfortunate bombing a few years back. And a very big part of why humanitarian aid was deployed to the correct areas and all of that was because very quickly we could get a picture, understand exactly where the damage is, the type of damage that has happened, and be able to direct the teams to the appropriate areas. Of course, parcel boundaries and land cover. We have a really cool land cover application. I'm not sure if you saw it. Please be sure to check it out. It's on the Living Atlas. And for, I think, every square meter on Earth, it says the type of use for that land. So is it, crops? Is it forests? Is it roads? Is it like urban area? All of that. That's all available, and that's actually free online. So oil spill detection, of course, that's extremely important. So being able to detect when oil has spilled in a specific area in the water, and to be able to kind of mitigate those issues and reduce the manual effort of finding, where the spill has basically kind of uh, spread to, and how to automate that ability. But it's not just all, purely geo AI. It's not all just about finding finding building footprints or roads or points on a map, right? In some cases, we've got the case where we want to be able, surprisingly, I was very surprised by this when I found out not a lot of governments actually collect where they put signs, like, and what those signs on the road are. So you could randomly decide to put up a stop sign on your road if you want to. No one would know. So in order to mitigate that, the solution was, in this particular case, you could easily drive around, right, with a camera on top of the car. And not only is it going to detect the signs, it's also going to do the optical character recognition. It's going to automatically read what type of sign it is. So is it a stop sign? Is it a wrong way sign? Is it a one-way sign? Is it a specific speed limit that's being set, right? And all of that is not only being collected, but also being geotagged. So very quickly, you've got something over here where you've got all of the signs on the road that are telling you, oh, okay, these are the different signs. And then if you want to maintain them, do some, any kind of checking for their health, making sure that they're still there, and no one decided to remove the stop sign because they want to, run an intersection, then very simply, that is very possible.
Yeah, sure. So having seen what AI can do, what kind of the results that you can get with the AI, with the samples that you collect, and with the results, what you see for crack detection, for vehicle detection, how this actually works. At the back end, there should be some kind of a workflow, right? How this actually flow, what kind of life cycle we are talking about. When we start AI, for example, if somebody hasn't used AI and you are starting using the ArcGIS Pro, we say that, okay, we have a nice lot of tools, advanced tools that are available, there are models available, but where do you actually start? Where do you actually start? So the life cycle is very interesting. So these are something like, for example, in the morning, we had a session on image management. In the morning, we had a session on image management. Most of you are attended. So if you're able to align the image management activities, and okay, these are the images that I'm going to take, and then do an advanced analysis, particularly right from classification to object detection, to expanding it to the ultimate of AI. So this is where we are starting. So the first thing what you do is start about labeling. Yeah. So there is something called AI assisted labeling that we can make it available in the ArcGIS Pro desktop. And then once the labeling is correct, once the labeling is done, labeling is something like you're going to pick up some of the objects. Okay, identify my plates, fights, identify my buildings, identify my trees. So there is an AI-assisted labeling tools are available, which will make you to collect those labels. Okay, I collected the labels. What next? So when I collected the labels, data is already prepared. I have to make the system learn it. For any AI to work proficiently and in a much better way, I have to make the system learn it. So how do I learn it? There are tools, auto deep learning tools that are available. I churn, it's kind of I will not actually say data mining, but it's kind of that I want to make the data to learn it and then further improvise on it. Maybe my accuracy might be reduced. I have to add more data. Maybe my accuracy still I want to improvise it. I have to add still another more data. So how I'm working on it, what kind of labeling again, the labeling, collecting the labels itself is an art. Collecting the labels itself is an art. How do I collect it? Do I collect it in a random way? Do I collect it in a very ordinary way? Do I collect it in a very organized way? For example, I have an image of, let's say that this area, Al Bustan area, the hotel area. I don't collect only in this hotel itself. I have to collect surrounding areas so that I have a generalized labeling collections. I have a generalized labeling collection that is used for the data preparation and then to train it. Now, once I train it, I have to I have to take this trained data sets and using this multi-feature extraction tool that is available, I'm going to put in another area for testing, which is inferencing. I'm going to infer these data sets and make sure that whatever the task I have created, whatever the labels that I have created, whatever the training I have done is giving me the exact results on it. And once we have the exact results, that's where we are going to start detecting these objects, that we are going to work on this and analyze to derive a lot of insights on this. You want to have something on this?
Yes, actually, I just wanted to highlight something over here.
Yeah.
If you've been doing machine learning or deep learning for like maybe 10 years or something like that, the idea of never writing a line of code was not something that was even imagined. I remember the very first time, like, it's how do you even just do it all via user interface? Now this is all completely done through user interface, right? The deep learning, the training, well, the data collection and labeling. Well, the data collection itself, because that's a very big aspect, right? And then the labeling. Now the labeling, you know what? When it got so good, we were manually, selecting, manually digitizing. That's when it got good.
Yeah.
Like that's when things got great. And then now there's AI assisted labeling. So you just say the planes, right? And automatically ArcGIS Pro just goes in there and goes like, oh, okay, that's the edge of the plane. That's the edge of the plane. No one has to actually sit down and go like, okay, yes, those are the points for the plane, right? Do what, 10, 12 points at least per plane. Think of the shape of the polygon that would surround the plane specifically. And again, just like Kanan was saying earlier, you do have to make very specific decisions about how you're going to collect that data, right? So if I'm collecting swimming pools and I decide, okay, I'm going to use rectangles, right? But not every swimming pool is a rectangle. And then if I put circular swimming pools within my rectangle, then that will mean that I'm also including tiles, which is going to confuse the model. Or I am just going to use the area that is, the area of the circle that would fit within the rectangle, but then I'm actually not counting the entire area of the circle itself, only the part that the square that would fit within. These are all very specific questions that need to be thought of. Okay, then if we go like a freehand polygon, basically, and that's something that you're going to need to draw, and that's something that's more complex and it's going to take more time. So that's something to consider. And again, the training, right? When it got really good, it was part of a user interface. But then now there is AutoDL. And what AutoDL does, auto deep learning, it just goes and tries different models. Like it's not, okay, I'm going to run this model, wait for the result. Oh, no, sorry, you need to adjust the learning rate a little bit. Okay, now what about 0.015? Run again, wait 3 hours. Okay? What AutoDL does is that it basically just puts in a queue a whole bunch of models for you to try, and then it just goes through them and gives you the results for that. So you have the ability to basically run it overnight, go to bed, right, and then wake up and have the results right there. And again, when the feature extraction was great, it was part of the UI, but now it's even better with the multi-feature extraction. You're not just extracting one thing. You're not just extracting, oh, show me, this model only knows planes. Nope. This model can know planes and cars. This one model can know both. And that the ability to do that multi-feature extraction is just good. I think what I'm trying to say is just that the amount of progress that things have made in that really short amount of time, and how much easier things have gotten within maybe the past 2 years or something, is just mind-blowing, to be honest.
So also we have to look into the time factor also. That's considerably decreased.
100%. Yeah. No, probably more than 100%.
Yeah. So what you have been doing, collecting the objects, doing some kind of classification manually, taking days. Now it is going into hours, right? With the system that we have, everything has been reduced. So you have a lot of information. So you have a lot of things that you can be extracting in a less time, much more accuracy way. Yeah. So this is of the inferencing things. Here.
Yeah, so this is just an example that's running survey 123, right? And basically with that collection of data that's happening over here, we've got the user, and simply just by pointing the camera at the type of plant that they're collecting the information on. Just going to wait for it to switch there for a second. Right. Well, first of all, it's detecting the already existing objects. And that's based on the existing model that's within Survey 123. But then
I think
you can also add your own model. So for example, for the different leaves of the trees, and it would automatically detect it.
I picked up this picked up the speed sign actually.
This is that was a okay. So what we're trying to say is that with Survey 123, you've got the capability to use the existing models that would already know objects that are just common out and about in the field, right? A car, speed sign, etc., something like that. But also, you've got the ability to add your own models within it for very specific things like, oh, this type of leaf is from that type of tree, or this type of leaf is healthy while this type of leaf has a specific disease that needs to be mitigated in one way or another, right? So just things like that.
Yeah. So once you have this kind of an, the learning cycle, how the life cycle of machine learning works out, we are trying to identify the data source, what kind of data source that we are going to use. So the data source talks about imageries, data source talks about vector and tabular data, text detections. So there are a lot of sources where you can use your AI, and then the machine learning can work with various data types on this.
So it's very common to think, okay, imagery.
Oh, imagery, yeah.
Right?
Yeah.
Imagery is AI. No, it's not just imagery. We can use text, completely unstructured text, by the way. I've seen many examples where tweets are used, right? To do things like, what do people think, that was an interesting one. Which team is going to win the Super Bowl in the US a few weeks back? And kind of detect the sentiment as the game progresses. Like as the match is happening, they're actively determining how are people feeling about the game in specific areas. Because again, keep in mind it is geolocated. So that's something else. Vector and tabular data. So things like predicting exactly where and when accidents will happen, things like that. That's possible.
Yeah.
So let's talk about exactly what a model is, right? A model, remember earlier I was saying like the main difference between just to generically say what machine learning is and then to say deep learning, right? What is this an example of? Machine learning or deep learning? Based on the little hint I gave earlier.
The cat and the camel?
Like the difference between machine learning and deep learning. Okay, so this is machine learning, right? Because there's only one layer. See? We've basically got the inputs. And I like to call these the eyes. Right? Because we've got these two eyes right here, and they're receiving input data. Okay? And then we've only got one layer of neuron in the brain. So it's not a very complex, not a very smart brain. Okay? And then automatically output. Nothing else in the middle, not so deep. Literally. Okay? Now, deeper models literally have more and more layers that try to understand more and more things. So what this layer is going to try to understand is kind of like that example about my sister earlier, right? Well, animal, 4 legs, doesn't really speak. Very simple analysis, very simple construction. But then later on, with more tests, right? More layers of complexity, more layers of thought, you can then start to analyze further things. Now, just to highlight to you, this is literally a one-layer neural network. One-layer neural network. Most good models right now are 256 layers and more. So that's kind of just to give you an approximation of how.
Now you brought the nice technical term, neural networks. So it actually works on the network. So how we perceive, how human brain perceive, that's how it's like you are going to build your models. So what kind of results I want, what I am looking into it, and what kind of results I want. So I'm going to build the models based on this. So it's a kind of a neural network. Thanks, Ahmed. That's a nice word, actually. Okay. Yeah. So when we talk about models, as Ahmed was explaining, we have pre-trained models and we have custom models, right? Pre-trained models, yes, we have hundreds of pre-trained models which is where making AI approachable, where AI was thought, oh, can I do that AI? Like Ahmed was saying, I have to do a lot of codings. Is AI easy for me? Now AI is very easy for you. AI is very easy for you. As it is said, it's very ideal for common use, object detection, classification, clustering. Yes, you start using AI. You open Arc Pro, put the image, because we are just going to start a demo kind of an image, the image only. So I'm just quoting that image. So the pre-trained models are available. What do you want to detect? I want to detect the pools. I want to detect the buildings. I want to detect the trees. I want to detect for example, oil pads on the petroleum sector, right? So something like this, I have pre-trained models available for me. I have to input the image, define the models, and see what is the results. Now the results for you, maybe it may be 50% okay, 50% not okay. Okay, you can still refine it. You can still go ahead and refine it. Now there comes the custom AI models where you can actually go on, for example, okay, this is the example of a pre-trained models. We have over 60 plus pre-trained models that are available where you can do all these kinds of feature extraction, result-oriented analysis quickly. You can do it. Then when it comes to the custom models, I'll come back to this. When it comes to the custom models, we are going to do a stepwise practice. What is a stepwise practice? I'm going to identify the suitable data. First thing is the data. So the core part of AI or core part of GIS is data, right? So we need to have a proper data, get the data, collect the samples, do the testing. That is more important. So if you say, okay, I have collected the samples, everything is fine, 100% is okay. No, I have to test it. So when my test will tell me whether my collected samples are okay, accurate, or not okay. Now, accordingly, I have to refine my samples. And then I have to rerun the test data and improvise my results. That's where the custom model comes back. So what happens in the pre-trained models? The step one, you choose the tool, you select your input, you extract it. Very simple. So depending upon the requirements, you can use either a custom model or a pre-trained models. Yes, Amit.
Yeah, I was just going to add that basically the main difference between what's a pre-trained model and what's a custom model. Okay, and I'll show you that there's like a reason I started out with that funny story, because it feeds into it just like that. A pre-trained model is kind of like having my parents there to tell my sister, no, that's not a cat. That's a camel. Because they already know that information. And that's exactly what those pre-trained models are going to do for you. If they are things that are already common scenarios that have already happened before, then there is already a tool to answer that question for you. And all you need to do is ask it, hey, can you please do this for me? Done. Okay. Now, where does a custom AI model fit in? Well, if it's something very, very specific, right? If my sister was asking for a specific car model from a specific year within a specific time frame and a specific screw that should go into it, neither I nor my parents wouldn't have been able to answer that question. They don't have that information. What will she have needed to do? Easy, research it. She would have needed to collect the data, understand that data, and then understand, oh no, wait, I didn't get that part correct. I need to refine. And then finally be able to answer those questions herself. And now she has become a pre-trained model for someone else if they have that same question. So that's kind of the main difference between pre-trained models and custom AI models, and also how a custom model could then be used as a pre-trained model.
So when we connect this example, I can even connect to the image processing. Previously, we have been doing that unsupervised classification, supervised classification. Remember that? How many of you know about it? Unsupervised and supervised, right? So what happens in unsupervised classification? You tell the system, I need 7 classes. So basically, depending on the spectral values of the pixels, it classifies it. It doesn't know whether it is a water body, it's a building, it's a grass or something like that, right? And then you interfere in that and then redefine the results. That's the unsupervised. When I say supervised classification, we in front of the monitor, we interpret the imagery. We say this, classify this as a building, classify this as a water body. Now I'm defining the classes, and then I'm trying to make the system learn, right? So that's the way of understanding pre-trained models and custom models. That's an add-on thing. Sorry.
Yeah. How many pre-trained models are there for free, 100% on the Living Atlas? Over 60 of them. And again, every single time we show this slide, we have to refresh it because they keep adding new models. And they are, in many cases, region specific, by the way. So we have data, we have pre-trained models specifically to detect buildings within the region, within the Gulf region, right? And multiple other examples. I think there's roads as well. It's already there. It's free, right? Just ready for you to use.
So the choice is always yours. Yes, that's the interesting thing. You want to take that from here. It's nice, actually. So we have the pre-trained models, which is very easy to use because you already have, as Ahmed said, you are ready to use. You know what exactly you want to use, the minimal step, 1, 2, 3, you get the results. But in the custom models, you as an interpreter, you as a specialist, you have to take care of all the data collection part and how you are going to train this. And for the pre-trained models, yeah, it is fast deployment because you don't have to do anything. And in the custom models, it's a time intensive. Maybe you take the whole UAE, you want to collect samples of different classes. It may take some time for you to take the classes, make the system learn, and then work on this. All right. And flexibility, no, the pre-trained models are fully block packed, and then this is what you have it. And custom models, you can really customize it. I can add more labels. I can add more training data sets. I can remove some of the training data sets depending on the accuracy of the results that I get, right? So that I can do it. And there are common tasks that you can use it for cases like we said, building extraction. We have the pre-trained models. For the custom models, let's say I want to detect any, let's say, fire damage. Fire damage, I want to identify which of the buildings are fired or damaged, which of the buildings are not damaged. So I have to identify this visually. I have to do some interpretation and then say, okay, identify these buildings which are not damaged and the buildings which are damaged. You see? So that way I can define the custom models. Yeah. So when we talk about the machine learning tools in ArcGIS, so now we are going to get into the application directly. There are a lot of tools that we have it. We have organized in a way of classification, clustering, and prediction. And there are more tools getting added to it. There are more and more tools getting added into it. Yeah. So there is a dedicated GeoAI toolbox that is available, and you have a lot of tools that has been used for feature and tabular analysis, image analysis, text analysis, and time series analysis. So GeoAI puts everywhere. I mean, you can put GeoAI in this all these sequence actually. So there are a lot of analysis tools. You want to add something on this? It's okay, fine. Right. So we'll come to actually the demo part of it. So to begin a demo with it, the first demo is going to be very basic kind of a demo where people say, Ahmed, Kanan, I don't know what is AI. How does ArcGIS Pro works in AI? Here is the demo for you, right? So what we are doing is we are going to collect the palm trees. We are going to collect the palm trees. So when we talk about collecting the palm trees, first I'm going to collect some samples of the palm trees. So I'm going to define the classification, my AI classification. So I'm going to say, okay, I'm going to take some labels. As I told you, as a life cycle, I'm going to take some labels. So when I take some labels, I define my areas. I go to that particular area and then choose some of the palm trees as I interpret. Remember this, we always tell what we visualize it, we are going to collect it as a human eye. So here I'm going to collect some of the palm trees. And similarly, these are one areas I'm collecting it, but I have to collect in multiple areas. I'm going to preserve it or save it in my label database as a palm training database. So I'm just going to save it. Similarly, I will collect in multiple areas. So what I'm going to show you is, for example, I'm just going to add this layer into the ArcPro to show you how the palm trees have been collected. So I have collected for one area samples. Similarly, let me see if I have collected for the other areas. I already collected it considering the time. I've added some more palm trees. I already collected preset everything. So if you go to the next area, there are some more palm trees collected. If you go to some other area, now again, in this also, the palm trees, you can collect the young palm trees, you can collect the more matured palm trees, you can collect the palm trees with different spectral characteristics. You can classify it, but here we are considering everything as a palm tree. We are considering everything as a palm tree. So once you have this palm tree collected it, then what we do is we try to export this training data to the system to make sure that these are the samples the system has to accept and then learn. These are the samples the system has to accept and learn. So we have an export training data for deep learning. So we export this into chips actually. So I'm going to run this training data and export it as a chips. Just few minutes, it will just run through it, and it just exported it. Once it gets exported, I'm going to train this model, train deep learning model. I can just train it based on the export training data what I have. So I'm just going to put it. I'm going to define the model type also here. What kind of models that I'm going to use. I will show you those models actually in the next demo. But because I just want to give you a workflow how the model actually works. So we are just going to see how these models are going to take up actually. So I train it. Once I train it, I have the DLPK. If you see on the other sides, I have the DLPK file that has been generated for me. Now I'm going to use detect. So I exported it. I trained it. Now I'm going to detect the models, detect the objects. Detect the object in the sense I'm going to detect the palm trees. So when I say detect the palm trees, it automatically goes to the chips I exported as an image file. Remember that? The training data sets. And then what it has learned from the training data sets, it'll run through those models and it'll go to the image sector by sector and it'll say, okay, Kannan has given me this palm tree. Okay, let me also pick up this palm. This palm tree is similar to this palm tree. So it'll identify all those palm trees and give me a result for me as an output data set. Now, not only I can do this, I can also even enhance or I can extend my demo to an extent saying that which are the palm trees are in good health, which are the palm trees are not in good health. You know, I'm not only detecting it, I'm further using the tools, the analytical tools, the capabilities of ArcGIS, AI, deep learning, plus other geoprocessing tools to identify the palm trees plus the health of the palm trees. So what I can do, I have certain raster functionalities. I'm going to use certain raster functionalities and then say that, okay, show me which are the palm trees that are in good health and that are not in good health. So I'm just refining my results, making sure that I don't have much of the overlap between the palm trees. So taking into consideration, I can convert these polygon squares, which has been detected as a palm trees as a point. Then I'm going to use some of the raster functions which is available in ArcGIS Pro. So I'm here generating an NDVA factor on the imagery. So once I have an NDVA factor, I can still further use some of the analytical tools to define what exactly my health of the palm tree. So let me just quickly go to the other session. Just a minute. I'm just going to do a, yeah, just considering time. So if you want to have further discussion, yes, I'm available tomorrow. We can just look at this and I can brief you more also. Now here, it talks about the classification. I've done a classification based on the tools that is available. And then I've defined those classes, the health of the palm trees, where the palm trees are really not healthy, where the palm trees are healthy. You know? So I have not restricted myself collecting the samples. I have not restricted myself training it. I have not restricted myself detecting it. What I'm doing it, I'm enhancing my results. So deep learning helps you to the deep learning helps you to take your assignment right from the start of identifying, detecting to the health analysis, the one process fully. So I'm getting able to get the workflow on it. So that is about the palm tree detection. We have another one, as Ahmed has pointed out. This is the living atlas, and then we have a lot of DLP models that are made available, and it is getting refreshed, right, Ahmed? Yeah. It is getting fully refreshed on it. And this one example is using a model called TextSam, where it is going to detect you the boats. This is a pre-trained model. The previous one, what I created was a custom model, which means I was collecting the samples. Remember this? And here it's a pre-trained model. So I just give the input. I give the model which I downloaded from the Living Atlas. It automatically runs through the model and it helps me detecting the object. So here it will detect all the boats. For example, this helps you to detect me all the boats, detect objects using all the boats. Yes, Ahmed, for you.
That was it. That was completely ready, right? All we needed to do is download the model, show it the image, and tell it exactly what we're looking for. We're looking for boats. Found the boats, automatically labeled them right at the end there. Okay. Now, in the interest of time, I think we have a little bit more demos, but I think I just want to skip to the AI assistant so that we have some time for a little bit of an open discussion.
Q&A. Yeah, good.
So in general, AI assistants, everybody here has at least seen ChatGPT being used and has probably used ChatGPT themselves. And it is, that kind of assistant capability is what we want to provide our users within a geospatial context as well. So, within ArcGIS. So there are kind of two types of assistants that we're working on, and some of them are already available. So things like that are already in Survey 123, but also as well things that are coming in the near future that we also kind of wanted to give you a little bit of a sneak peek on, so to say. So when it comes to the embedded assistants, like things like in Survey 123 and within ArcGIS Pro and Business Analyst, we've got these embedded assistants that could just do these little tasks for you, like kind of like recognizing, all of those different models that we were talking about earlier, or even a conversational survey design within the survey builder itself. Oh, I want to do a survey that is about restaurant inspections. Well, automatically, that integrated embedded assistant is going to understand, okay, so it's restaurant inspections, that's the data we're collecting. We probably want to collect some things about the cleanliness of it, etc. And then it's going to show you that result and allow you to fine tune it. Now, I'm running a little fast here, but generally, with the general assistance, we're aiming for an experience similar to what is kind of seen with Microsoft Copilot and ChatGPT and all of that, where it's kind of very broad, artificial intelligence tools to answer any questions that you may have within a geospatial context. So over here, let's start taking a look at this sample. Right now, over here, we're running this sample general assistant. And again, very conversational, and everything that's been said so far is, I'd like to make a map. Now, automatically, the assistant won't have to respond and just says, okay, well, here's a map. What do you want on it, right? So then we ask, do you have layers for wildfires? And what it does is that it actually goes and searches the living for layers for these wildfires and shows me the search results. I can go click it, but I'll add the second one. So what it does is that it actually understands what, within that context, that's the second one, adds it on the map for me right here and confirms that. Now we can ask it a question, how many wildfires are there, right? And then it's going to tell me there are 371 total wildfires. And that actually uses the map context, by the way. Had I zoomed in, it would have given me a different result. And then we say, can you zoom to Argonne?
So it takes up the extent and then provides the filters. Yeah.
Now notice, we just said, can you zoom to Argonne? We did not give it, there's no layer over there that says where Argonne is, but it automatically understands to do that search. Now, it moves, how many wildfires am I looking at to show that, that it responds to the extent. And now it says there's 105 wildfires versus that 371. Now we say switch the base map to imagery. And automatically, that assistant is doing that for me. And can we say, can you change it to 3D? Now, this is something that I find really cool because it automatically switches it to a 3D scene, but then keeps that data that I wanted and keeps that extent that I wanted within that same area. Now, it says tilt the map by 80 degrees, right, to display that kind of three-dimensionality. And again, we're looking at that same data within that same point where we started. Now over here, I'm not going to try to read this, but it says vamos a poison, right? That's Spanish.
Yeah.
Okay. And it doesn't matter the language that's being used. Automatically, it understands and it responds back to me in Spanish, right? And it takes me to that specific area that I requested. Now over here, yet another language. I'm going to try to guess which one. And it automatically takes us to that area that's being requested. Okay. So language itself is not really an aspect with these assistants in a very similar way that it's not, with ChatGPT and all of these different tools, right? And of course, Arabic is 100% supported, concern for the region. So this is the kind of experience that we're hoping to develop within the future products of ArcGIS in general, where you can just get started and very quickly, through a simple conversation that you would have with your assistant, with your employee that's doing the work, all of that, reach that immediate result, that same result, but with the power of artificial intelligence.
So the intelligence is getting overloaded.
Oh, yeah.
Yeah.
Oh, yeah.
There's a lot of intelligence coming into ArcGIS Pro from the desktop level to the enterprise level. Morning I had one session where I showed the deep learning studio, and where you're going to use ArcGIS Enterprise with ArcGIS Image Server. You have the deep learning web application. You don't have to configure anything. There's a deep learning studio available with the models packed in actually, and whatever the analysis that you want to do with the images based on the model that is available, you still can go ahead and use in ArcGIS enterprise level. Yeah. So technology has grown a lot. Intelligence have been put a lot of information, and we are growing a lot and lot. So we want to have this other one, the vehicle one.
Oh, that was just a regular AI.
No, okay.
Yeah.
Okay, just continue.
Yeah. So yeah, and of course, something that is extremely important is, whenever these things are being done with AI, there is a very strong ethical responsibility to make sure that things are happening in the way that they should be happening, right? Very specifically. So this is why sometimes it could be seen that development is taking longer than possible, but also a very strong and important aspect of that is making sure that we are building things that can be used correctly and for the right reasons. And that's exactly what we're committed to do.
Yeah. So that's about AI, GeoAI, and GenAI. So the floor is open for Q&A.